this session is multidimensional property dynamics, time series, and technical data. First, I'm going to talk a little bit of distributed analysis using time series. My is going to be using cross-sectional data, repeated cross-sectional data. Then Sabina will follow with the chronic property management, technical data, and then dynamics of subgroup analysis. Most of these it's also covered in the book, the manual on multidimensional property. So we follow this follows very closely chapter 9. So one of the main motivations to have a multidimensional property measure or any property measure is to track progress, like to know if property is going up or going down. In terms of property, the main source of data, the main type of data we use to keep track of monitor progress in terms of property are repeated cross-sectional data. So where we have data for a representative sample collected in different points in time, but we don't necessarily, most of the time, we don't track the same individuals. We cannot say the same individual was scored in this, or that will require manual data, which much more or less frequent. So what I'm going to talk about is going to show a little bit how can we track change in N0 and in composite indices using repeated cross-sectional data. I'm not going to focus, I'm not going to even talk about some of the data issues that are associated with analyzing changes over time in NVI. Some of these issues, one of the main issues that require a lot of data is the identification of NVI parameters. So when you define a measure, or you now creating a measure, you have indicators, you have deprivation cutoffs, you have weights, you have property cutoff. When you want to compare in different moments of time, you have to make sure that all these parameters are exactly the same. Otherwise, changes might be driven not because of the progress on property, but because other parameters change. And this requires to questionnaires. See if the questions are the same, the codes are the same. See, sometimes requires dropping one of the indicators because of the temporary. We did this for 34 countries with the global NPI. So we had a recent NPI estimation and comparable DHS. All the indicators to make sure. Because the global NPI is always done with the best data available. When you want to compare, like what was done 5 years ago, maybe the questionnaire has changed, not the cases have changed. And so you have to make sure that everything means exactly the same. The indicators are exactly the same, that the professionals are the same. This is not how we look at it. You also make sure that look at the survey designs. What are the primary sample units, what are the clusters, the weights, the variables, make sure that when you bring those two together, they make sense. That's very important. Maybe you have to know very well some example when you merge information. Makes sense. They are represented at the same level. If not, you have to keep them represented. What I'm going to present here in this series is going to be for 2 periods, but of course there can be time for common period. Just to take it very fast, this is going to be more relevant when we go to the book and look at the book. We have T1 and T2, initial and final periods, 2 matrices of achievements, X1, X2, T2. I'm assuming that all the harmonization has been done, so everything is exactly the same. They are exactly comparable to M0, the other in different times. I'm going to talk most of the expressions that I'm going to show will be referred to M0, but we will do it easily for incidence intensity or the edit count, and this is, I think, everyone already knows. Changes in M0. First, easiest rate of change. So computing is the absolute rate of change, which is just the different two levels. So what I do, I have two M0s. You have M0 T2 and M0 T1. The easiest is look how much has it changed? Just take the difference. M0 in N2 minus M0 in N2. But we can also look at the relative rate of change. It's just the difference between the two periods as a percentage of the M0 in the first period. So let's go on an example, just to make sure we are all on the same page. We have a country that has reduced M0 from 0.5 to 0.4. What was the absolute rate of change? 0.1. What does that mean? You already did. Yes. It's also the mean total, so the relative rate of change was 30%. But what it means when I say that the absolute rate of change was 0.1? It means that from all the derivations that a group of people in that society could suffer experience, we have removed 10%. We have removed 10% of the derivations that group of people in the worst case scenario would experience 20%. No, 10% that were removed, there are still 40% remaining. If I the relative rate of change, this means M0 and reduce at the rate of 20%. Question. Why do we look at these two rates? Why not just stick to one another? To compare. Yes, but you can compare to the introduction of the rates. Why do we need to do the rates? Different bases. So, this is the absolute. So, in the absolute, we just compare the two rates. But the end value of the relative change is much clearer when we have countries with low poverty, with levels of low poverty. So, for a country that is that is very poor, by a kind of paying high rates of change, absolute change. Because if you have a poverty of 0.5, you can reduce it 0.1. But if you have a level of poverty of 0.1, it's much harder to completely take off the 0.1, and you cannot reduce 0.2. So it would be a bit unfair to compare just using the absolute rate of change, because small values could be just because the country is already at a low value of poverty to start with. So by putting in relative terms, it means that although maybe the country has reduced much less, one country has reduced 0.1, the other country has only reduced 0.05. But that 0.05 in relative terms might have been actually pretty high. And so that it is important for us to also not underestimate the progress of countries that already, although at low levels of poverty, are making an effort to bring it up to zero or closer to zero. Do you understand what I mean? So it's just we should have both. So we look at both, and depending on the level of development of a country, that gives us like, is this moving okay or not? Maybe it's not diminishing 0.1, but it's like a rate of 10%. Not bad. When you do comparisons between countries, like we did in 34 countries, they don't have data for all the same years. Let's forget about it. No. Look at the DHS, and one is for 2008, the other for 2009. So when you have the two periods, they are not necessarily the same distance. For instance, an extreme case in our latest set was Gabon. Gabon, we had a DHS for 2000 and another for 2012. So we are talking about the change in 12 years. Tanzania, we had a DHS for 2008 and another for 2009, only 1 year. So when you make comparisons, sometimes you have to, most of the time in this case, we have to analyze. We cannot talk about the rate of change with different periods of reference. It's not like if you have 12 years to reduce poverty, it's not the same as you have 1 year. So we look at the annualized rates. For the absolute annualized absolute rate of change, you just divide the difference for the different years. In the case of Gabon, you divide by 12. In the case of Tanzania, you divide by 2. in a relative of rate of change. You have a compound rate of reduction rate between the initial and final phase. But it gives you the first one, and that's also in the second. So here we have an example again, some numbers. The first, these columns give us the values in year 1 and year 2, which is the policy 2006, 2011, 2005, 2008, statistical significance, and then we have annualized change, so we can already compare. We already analyzed everything, so the numbers should be analyzed. My first question is, which country has reduced multidimensional poverty index was more successful in reducing the multidimensional poverty index? Performed best. In this case, actually, it's indifferent. But ideally, I would expect the US is in both. Nepal. In this case, Nepal is amazing. He actually reduced poverty fastest in both absolute and relative terms. And he's actually started performing in our 34 countries. Yes. Yes.
The MBA will 0.25, 0.1, and 0.21 in year 2. Then from there,
we test now. We test the difference, the test the change. So we have all the same, we merge all the data for that country, and then we test the change. But it's one of the issues here, because we don't test the analyzed change, we test the overall change. So it's easier to have an overall change significant to the leader. Yes. Within the individual. So, picking up Nepal has performed wonderfully, is our best. Is the country has reduced poverty fastest, both in absolute and relative terms. It gets more tricky, as you have asked, it's absolutely right. When I ask who performed better, best, Peru or Rwanda? Why Rwanda? Oh, that's very interesting. Actually, it's because, yes, it is ignoring statistical significance. Peru? Why Peru?
Because the percentage change is more, even though in absolute terms is less.
But someone might argue oh yes, he has done better in but he doesn't test like compare it. It's almost a big difference in the absolute terms. It was really low.
But it depends where you start.
Exactly. So you can make that argument. So my point is not as easy to answer. If you choose that, it depends on your sector. But then you will always look at the relative, and the relative might show you like sometimes very small, which for a country might be huge reduction in absolute. So when I explain, I focus on the low, but if you want to focus on the high, you'll say it will always be running again. It's going to be always tougher for them because they already have high poverty, like to manage a big. Yes. So you have to look at both. So in this case, like it's not very easy to say. One is to perform good in terms of absolute and another relative. So it's much harder to say. In terms of interpretation, how would you interpret this minus 4.1? What does minus 4.1 means? Here in the case of Nepal, and I'm talking about the incidence. How would you interpret that? What does that number mean?
Make sure that everything is by 4.1 anyway.
But 4.1, what percentage point? Exactly, percentage point. And that's what I was looking at. In absolute terms, what we are talking about when we talk about the headcount ratio, reduced from 64.7 to 44.2, which means in annual price. So each year, per year, Nepal has reduced the incidence in 4.1 percentage points. When I talk about Peru, for instance, at -6.9%, it's different. Peru, between 2005 and 2008, has reduced incidence at the rate of 6.9% a year. So absolute changes will be percentage points. Relative changes is a percentage, but it is a percentage with respect to the initial point rates of the start. We reduce already 6.9% a year. 6.9 of what you started with. And just as the graph of the examples that we had, annualized absolute change, that's performance, as I said, follows Nepal. Nepal did very well in terms of absolute. He was not the best in relative. In our biggest together, but he was among the best. Rwanda, Ghana, Tanzania, Cambodia, there are all countries that have high, above minus 0.15 and 0 per year. Madagascar can be very bad. Madagascar actually increased poverty in individuals. Armenia, and Georgia, Guyana, and Colombia, their increase are much smaller. Although this change when we go to relative terms. Armenia, almost 20% a year. Armenia had a very low level of M0 to start with. So any reduction would be always a big percentage. But Dominican Republic, Libya, Egypt, and my Nepal. Nepal, in relative terms, almost 10% a year. Not bad. The ones with lower increases, Senegal, I think it was not significant. Nigeria, Pakistan, when we going back again to the example, when we look at Rwanda, 2005-2010, we have a change, absolute change per year, annualized absolute change of minus 3.4, and a relative change of minus 4.4%, which are not good. Based on this information, can we say that the number of poor people in Rwanda has decreased during 2005 and 2010? Why not? It has decreased, but not this way. Why?
Because we don't have the population.
We don't have the rate of growth of the population. So what happens? I may be reducing poverty at minus 4.4%. But if the population is growing at 5%, the percentage decreases, but the number increases. And so in order to reduce, there's a question. Yes.
This was already raised, right? If you are doing like, if your population is increasing by let's say 5%, then it will be captured by the headcount ratio, which is 66%.
No, because the headcount ratio gives me a proportion. Gives me the proportion of people who are poor in each year. So the proportion of poor people might increase between the two periods. But if my population before were like the extreme was 100, was 10, and I had only 2 people that were poor.
Okay.
So I have 20% of poverty. And then I have in the end 100% of the population grows to 100. Sorry? With 15 poor. So I have, thank you very much, 15% of incidence. So the head count reduced from 20% to 50%. Approximately numbers that are crazy. But the number of poor increased exponential because my population increased super exponential. So this is always the division. So it's the number of poor divided by the population. So the numbers, the percentage might increase, but if the population is increasing,
So the number will be higher.
good. Let me show you this. What we did here to get these numbers, to obtain the number of poor, we multiply the incidence by the population. And so we presented this is the population and the output. This is those values that were there multiplied by that gives you the numbers. And in the case of Rwanda, it actually decreased. So the population has increased, but at a lower rate than before. But in the case of Senegal reduced the incidence really small, like minus 0.1%. But in absolute terms, it increased 1 million people. Because the population is growing at 3.10.
I was going to say, in economics, we think it's kind of analogous to these with nominal or real rates, where in a way, like population growth can be sort of like inflation. And so if we want to really capture what's going on, you have to adjust for that.
Yes, okay.
Sorry? Have you adjusted the population growth?
No, will give the percent in terms of proportions. So no, it doesn't matter.
We have adding 20% of decline. Can you go to the graph and say the 20% decline? Other one will be?
This one, yes.
So, practically it is a practical physics, it is a data manipulation. Because the 20% reduction of hydrogen energy is MTL. So is possible happen in the case like if I say 20% growth rate, you know China is growing at the rate of 10% of growth. So when you have everything are in the cohort, 20% decline number is something theoretically possible. No, but my problem is such a big number.
It's such a big number, but I don't have it here. So the initial number is like 0.003. I don't have that. It's stable, both is stable. It's really small. So a little change is a big percentage. Because the country where the level of poverty is really low. And it's just, when you divide, it's such a small value, it becomes a really large percentage. When you're talking about other countries like Niger is a peak, the denominator is a huge number. So the changes will always be smaller because it's just a matter of how you present the information. So in order to reduce the absolute number of poor people, we have to make the incidence reduce at a higher rate of reduction than the population growth. So it's important that when we are talking about these, looking at the changes, that sometimes to go down to her, what does this mean in terms of number of people? Talking about nice percentage, but the number of people, what does this translate to? Because in the case of Senegal, we see the negative side, but in the end, it's an increase still on the number of people. And as Hugo says for population growth, there are other demographic shifts that might have an impact when you interpret the results, when you interpret these changes in the zero or incidence. The rural-urban immigration, and also you want to shift from one side to the other, and when you look at the percentages, you also have the accurate picture. Internal and international migration shocks, demographic patterns, aging, so suddenly there seems to be no deprivations in school attendance, or they reduced a lot. It might be just because we have less children. These demographic shifts also might affect comparisons across time, and also comparison across groups. Sometimes when you do competition by groups, remember you always have like as a weight the share of that population group. But the shares of the population group might change. Especially talking about that 12 years, other things can happen. Continuing on to dimensional changes, as you also talked in the previous class, the MPI can be broken down in its indicators. And the same we can do with changes. We can also.
Sorry to interrupt.
No?
The previous slide, when we were talking about the demographic shift,
Yes.
those are non-trivial. How are they taken into account?
They are not taking, that's what I want to raise the awareness. It's that when you look at the changes, those formulas that I could prefer, the annualized absolute change and the annualized relative changes, they are not taken into account. Those are proportions of the privations of population. And so, when you want to make sure, I gave you the example that was the easiest of the growth in population. When you go interpret those results, you have to be careful to see how that translates in numbers of people. Because in my examples, population growth might shift not shift, but you might think, oh, this country did pretty well. It reduced poverty in 4%, but it was a country where there is a high fertility rate, like population is growing super fast, 8. And so you say to we have reduced poverty very fast. But then when you think about the number of people, oops, no, actually the number of people has increased. So what I'm just saying is I have presented those formulas and I said, you should look at these two to see how things are going. But it's not just that. Then you should also look what does that transfer means in numbers. And for instance, comparisons urban-rural. In rural areas, in urban areas, it's such a low percentage. What's that in number of people? If there are more people living in urban areas, that low percentage, and now I'm not talking about changes, but I'm talking about numbers, might actually be a big number. So the point of this slide is just try to bring sometimes to the people. Don't get stuck on the numbers, because they are percentage, they are proportions, and so there is a magnitude effect that is lost.
How about the demographic shifts systematically to the dimensions in the mix?
The demographic shifts depend, like the aging, it might be like, for instance, yes, it's say you started with attendance was such a big deprivation, and then it reduced 10 years later, it's so low, we made huge progress. It might be just those kids have aged, they are not in school age anymore, and people stop having kids. It's not stopping, I'm saying, so it might be a reduction on the number of children in that age group, might appear to you as a big progress, the government did so well, but it was not that. That's just a result of the demographic shift. So I'm not saying for each slide what's the solution. I'm just trying to say, be aware. Be aware when you are interpreting your results in changes. What might be driving that results might not be policy, but might be some of these kind of changes.
So in that way, you are saying that this will be standardized for the demographic factors. This will be standardized for the demographic factors. This will make it standardized there, right? So that it will compare with
I don't know I'm not saying that it will standardize. I'm saying when you are interpreting, you have to look at the numbers of whole people for instance, to see that the conclusions that you are taking are actually accurate. So when I said, for instance, we said that poverty has reduced. It's true, the conclusion is true. Poverty as measured as percentage of poor people has reduced. But in practice, it hasn't. In practice, the numbers of people it hasn't. So I'm just trying to raise awareness for that. Sometimes we get stuck on the metrics, on the numbers, but we are not seeing. Or in the case of the school attendance, school attendance might reduce, especially if we are talking about large periods of time in between. You see that school attendance has reduced so much. The government makes huge progress on that. But when you get part of the progress, it's not the government, there is a change on the age period of the country.
So that's why in demography is to be standardized. The standardization take into account. So extra plus C. So that even the rates are comparable over time.
But that's not, I don't have
There is some standardization exercise may help to
yes. So going to the dimensions. Então, as I was saying, you've seen that the MPI can be written as a weighted average of the sensor that counts, where each sensor counts as the weight of that image. What are sensor that counts? We all know what kind of sensor that counts at this point. Yes? Exactly. It's the dramatic proportion of people who are poor and deprived medically. The change, the annualized absolute, or the absolute change in the MPI, or the annualized absolute change, can be also written as the weighted average of the annualized, or the absolute change in the sense of that. It's the same, it translates for changes. And here what I have, it's for Nepal, the indicators, and both have shaded the raw head count, only the percentage in the population that are deprived of that indicator. And the one to the right, the censored head count, percentage of people, and I don't have here the percentage of people actually. I have the change. So here it's like the change on the censored and uncensored head count. So for instance, for nutrition, the percentage of people who are poor and deprived of nutrition has reduced 3 percentage points per year between 2006 and 2011. That's how you interpret this result. And my first question is, which indicators have reduced fastest? Acid on chips, we have both of them, like both the censored and uncensored. Electricity is the second one. Then, cooking fuel. Although cooking fuel already is something different. The censored head count has reduced -4 percentage points per year. The raw, much less. See what?
I know we're supposed to share little stories once in a while.
Oh, cool.
A really good friend of mine, actually, from grade school. I went to this little Montessori school in the West. And his older sister is 2 years older. And she started a company in Nepal called Empower Generation. And it targets bringing these little solar lamps. But not them bringing them, but helping women in rural villages in Nepal create micro businesses and enterprises to sell the lamps to their village to stop the use of kerosene torches and other things. So I just thought of that one as something. I know it's a little different, but the kerosene torches cause a lot of cancer. And so they've actually been really kind of successful in doing this. And now with the earthquake that just happened, I think they've shifted a lot of their focus to say, like, how can we be helpful? We already bring solar lights and lighting sources. And that's one of the biggest things that I think that they needed with the cleanup and with trying to find people for lights.
Thank you very much. That's okay, you understood the idea. So you see that some of the indicators that perform seem to have made the reductions much faster than others, like for instance, school attendance seems to have been quite slow, both in terms of raw head count and censored head count. And now a different question. So the first is, which indicators are reducing fastest? And now, what indicator has the biggest contribution to poverty reduction? And yes.
Don't we need to know the weights?
Exactly. Now, when we talk about contribution, it has to do with the weights. Because first, we're just looking at the head count, and you see, it has gone faster. Electricity has gone, acid has gone pretty fast. But the weight of acid is very different from the weight of nutrition. So in third. So for 1 percentage point of reduction in nutrition is equivalent to a change of 3 percentage points there, because when you see the contribution, you have to account for the weight. The weight of nutrition is 3 times higher. 1 percentage point of reduction in nutrition takes you 3 times further in reducing poverty. This is what I was saying before, so the annualized or the absolute rate of change can be expressed as the weighted average of absolute rates of changes in censored head counts. So, as different indicators have different weights, when we look at the contribution, we cannot just look at the head count. We have to take into account the consideration, the weight of that indicator. This is the annualized change between these 2 periods, yes. So we only have 2 data points. The one to the left are the uncensored head counts. It's actually, again, is the change on the uncensored. So, what do you think was the indicator? Of course, you cannot know for sure, because this is required. But what do you think was the indicator that biggest contribution to poverty reduction? Where you vote, where you put your money. Nutrition. Again, it's nutrition. Because the weight of nutrition, the weight of nutrition more than compensates for the assets. So in practice, like the biggest contribution to the reduction of Nepal came from a reduction on deprivation of nutrition. Although when you look at the outcome, it seems like, oh, assets ownership as so much higher. But that's the ownership as a weight of 1/3. And then there's another issue here as well. Interpreting the real on-the-ground contribution of each indicator is also a little bit more complex. I would say, oh, nutrition has driven the reduction of M0. That's true in terms of numbers. But what does that mean really? A reduction in sensor account in nutrition may come from two situations. How can we reduce a sensor account? One thing is, I think what you're saying, is by reducing the deprivation of poor people in that area. So if there were nutrition is poor people, 5 poor people, before I had 5 poor people were deprived of nutrition, now only 3 are deprived, poor people are deprived of nutrition because the other 2, they stop being deprived of nutrition. The sensor account goes down. So reduce the deprivation of poor people in that indicator. And that's what normally we think about. When I say nutritional, the sensor account of nutrition went down. First thing I think is, oh yes, there's poor people are less deprived of nutrition. And that's true. There is another way, because exactly. Because a change in one sensor account or one indicator depends also the changes of the other indicators. So it might be that now I have less 2 people deprived, less 2 poor people deprived of nutrition because they stop being poor. But they are still deprived of nutrition. So the sensor account doesn't capture them. But what account captures that? Exactly. The sensor will keep a track of those people. So that's why you also look at both side by side. One gives you the change of deprivation among the poor, which doesn't mean just that their deprivation of food change. The fact that poor people stop being poor also changes their deprivations. And the other is among the population. So going back, a person becomes deprived in jail, a poor person has been deprived in jail, but becomes non-poor, even if still deprived in jail. What we just said. So now you look at Florian and cooking fuel. What do these 2 columns tell us? The sensor account has reduced much faster than the raw account, the sensor account. What does that mean? The poor but so why the raw account doesn't move equally backward? So if it was been improvement in cooking fuel for everyone, the poor would improve, the raw, the other ones would also improve. So that's the difference tells us that actually some people that stop being poor, that are already, that were accounted in their debt, are still deprived. So it reduced. So the deprivations in cooking fuel among the society have reduced, but they reduced much slower. So it means that some people that stop being poor, because they improve the nutrition, for instance, are still deprived of cooking fuel because the oil count is going slower in absolute terms.
So linear approach both will be good, right?
Sorry?
Linear approach both will be good.
Now they have to make it big. But that was a question on the textbook.
That's really cool
Because yes, if you are deprived of one, if you are already poor, so you have to yes. And since that people become poor, they still remain deprived in cooking fuel. So that's the main on the goal that I wanted to do. When you should look at both. You should look at compare the change on the deprivations of the society as well as on was you seeing, when you look at the poor, are you seeing real improvements on those deprivations? Or you are just seeing a movement of people getting out of poverty that remain apart from those indicators? Again, when you use repeated cross-sectional data, these comparisons will also be affected by demographic shifts, also by changes in the deprivation profiles of the non-poor. You can also not catch like maybe the people who are poor become more poor and change the lower accounts. So things in practice, I don't know. And the last idea, and I it was lots of things to share, so I already have away. And last thing is also very important to look when you look at changes, to look at changes by subgroups. So the breakdown of the MPI by subregions applied for the changes, absolute changes. And so it's good to see by groups, to see if there is a group, if the poorest, for instance, the poorest groups are reducing poverty faster than the less poor groups. Are they converging or no? Or maybe the poorest are going slower. And the way that we found useful to do it when we were writing this paper in 34 countries, graphically, was to put on the axis, on the horizontal axis, the initial level of poverty. And in the vertical, the annualized absolute change. So this is Nepal. And then what we do, let's see how are the regions. And we place the regions. And what does this mean? Tell me. It tells me, for instance, that Central Hill, the region in Nepal with the lowest level of poverty to start with, has the lowest reduction. While actually, one of the most, not the most poor, western terrain, the poorest region has the highest reduction. So in Nepal, it seems to be the case, you can see the trend as well, the poorest regions actually are reducing faster, at least in absolute terms. So it seems to be some catching up. And I don't put here the graphs on the other side, but this is not the case for other countries. For Mozambique, for instance, this curve was much more like this. So what that means, that curve, that line, the trend, it means that the poorest regions actually were reducing poverty slower. And so we would like to identify that, like know. Because when you see at the national level, the average might hide disparities in terms of changes as well, not just in terms of the absolute levels, but in terms of changes. I'm sorry, Sabina, for taking so long.
Any other questions on that? I think that's probably the more common and the more useful of this than what I'm going to do.
Not going to do 5 steps as well. You remember something.
So how many of you are working on panel data? Okay. So what I'm going to do is present 2 ways of analyzing multidimensional poverty using panel data. The first is to build a chronic multidimensional poverty measure. Okay? And the second is to analyze, decompose your panel sample into dynamic subgroups, that is, subgroups that have different profiles of poverty transitions, and analyze the transitions for those subgroups. I think I will probably not get very much into the advantages of direct decompositions versus Shapley and theoretical, but if people are interested in that, then I'm happy to spend a few minutes on that at the end. Is that okay? So when the data are panel data, then clearly what we know is we know the identity of each person across time. And so we know if the same person is poor in time period 1, in time period 2, in time period 3. We will know their deprivation profiles in each of the time periods and how those have changed. And so these data sets sound beautiful. Now there are always problems of sample degradation across time. And so what we are doing here is presuming that you have learned the techniques for dealing with panel data. Because they are distinct, we haven't been teaching them, we haven't been teaching whether it's standard errors or analysis, we haven't been teaching the treatment of panel data. So we presume that everyone in a sense is already up to scratch on those topics. And here we're simply going to focus on the measurement aspects. So the first topic is, let's extend multidimensional poverty into a chronic poverty. Now there are theoretically two ways we could use panel data and put it into a multidimensional framework. The first, and these names are very confusing, and we confuse ourselves with them, so I'm going to try not to confuse you. You'll have to tell me if it works. The first is to look at each indicator across time and see who's always deprived in education in every period, who's always deprived in health, who's always deprived in housing. And so in a sense, look at chronic dimensional deprivations and then identify people as multidimensionally poor if they are deprived in enough periods of these indicators. And a colleague, Mauricio Plaza, has performed and done that work empirically. But we choose a different order of aggregation. Rather than aggregating data by indicator over time, we are going to look at multidimensional poverty, a snapshot in each period of time, and then aggregate across poverty states. And the reason we do that is that policymakers really probably want to look at poverty across time. And so for policy purposes, you can do this, and there are also axioms about time that we satisfy, time monotonicity. The work that I'm presenting here on a chronic measure is joint with Sati Chakravarti, Mauricio Plaza, and Gaston Yalanetsky, and it's up online as a working paper. So basically, in 2009, James Foster developed a method of measuring chronic poverty, which is very much like the measure we've looked at for multidimensional poverty. That is, you set a cutoff across the number of periods in which people experience poverty, and this was for unidimensional poverty, is the topic of that paper. And it was his presentation of this paper that got me quite interested in that as a potential avenue for multidimensional poverty. And then you use a time cutoff in addition to the deprivation cutoff and the poverty cutoff to identify chronic multidimensional poverty. There are other classes of measures like M1 and M2 in multidimensional space, in time or chronic multidimensional poverty. You could also have different indicators that take advantage of the cardinal elements of the data if you wanted to. And if the time periods are not equally spaced, you could also construct measures that somehow take into account the distance of time between them. But for simplicity, we are going to presume that the time periods are equally spaced, and so we satisfy an axiom of time anonymity. And we demonstrate the form that can be used with ordinal data. So the paper presents the properties. I'll just mention them as we go along insofar as they're relevant. What is very important is the order of aggregation. You've already seen in multidimensional poverty, we aggregate first across people to create the CI score, censor it, and then aggregate across the population to construct the M0 measure. What we will then do is aggregate across time periods the poverty status of each person to construct a chronic poverty measure. So the order of aggregation, as I said, it could have gone in a different direction, and there are valid reasons to explore them all in terms of research, but this is the direction we've chosen. So we use these three cutoffs. As before, we're still in an ordinal world. We use a Z cutoff to identify everybody as deprived or non-deprived, dichotomizing the data to have a rigorous treatment of it. And then we implement a poverty cutoff. It's very important that we have the same Z and K cutoffs in every period. So these are fixed and given, as is the number of dimensions. And for simplicity, we're also going to presume that we have data for every person in every period. We all know we don't if we use real data. So we are restricting our sample to those for whom we have data in every period. And then we introduce a new cutoff, which is tau, which identifies who is chronically poor. So let's go through it. This is the matrix we began with. early on, the G0K matrix, so 0, 1 deprivation matrix, where 1 is a deprivation and 0 isn't. And this is the censored matrix by some k value, in this case k equals 2. And this is your censored deprivation vector, deprivation score vector. So this is what we are going to construct for each period. So you construct your censored deprivation matrix. You already know that M0, the censored head count ratios, the percentage contributions, all of these draw on your G0K matrix, the censored deprivation matrix. Now we're going to do something new. For those of you who like the notation, we are all quite opinionated about the notation we like. And some people love the identification notation. If you like it, you'll be right at home. Because if you think about when we constructed the vector here, we identified implicitly everybody who has a non-zero value in this column as poor. And then remember, I asked you to give me the head count ratio. So you manually counted, well, 1 and 2 people have non-zero values and 2 people have zero values. You could also have been a little bit more elegant and created an identity vector with 1s and 0s. And then the head count ratio is the mean of that vector, right? So that's much cleaner. So that's what we are doing here. And we're doing that because we're going to be putting together various matrices. So we have to reduce them to vectors to put them together. So we're putting an array of data into a new matrix. So this is I. That means the identity of whether that person is identified as multidimensionally poor or not in time period t. So this is, let's say, the first time period, given poverty cutoff k. Okay? So now we make a new matrix. So let's say we have four periods in our panel data sets. And I keep saying I should have changed this matrix so it looks different, but I didn't. We're now going to call the matrix Q of k. And now each column of the matrix is this vector, which is distilling the poverty status of the censored deprivation matrix for each period. So from period 1, you're simply taking the poverty status, who's poor and not poor, and you're putting it here. And so there are 4 people and there are 4 time periods. This is T4, not T1, sorry. T3, T2, and T1. So again, for each person, you are tracking, this person is not poor in every period. This person is poor, and we do say poor. They are multidimensionally poor in these 2 periods. This person is multidimensionally poor in every period, and this person is multidimensionally poor in 1 period. Now, in the most simple form, we are going to presume equality among the periods. And of course, we know that not everything is the same time period between the waves of the panel data, but we're going to presume that they are, and we are going to count. So we're not going to make a weighted, we're not ever going to add weights in this particular measure. We are simply going to count the number of periods in which a person is poor.
If you want, you can already change the weight. Right? If you
Not and satisfy the same principles. So this is where it starts to depart a little bit. Because if you want to be able to break it down by time period, you need the time periods to be equally weighted.
Yeah.
So for the duration measure that we construct, which I'll introduce shortly, overall duration and dimensional duration, and they are framed in terms of the percentage of periods in which people are multidimensionally poor. You can't have that same duration with weights unless you it's possible to do it empirically. But in terms of the properties, they have to be redefined. So this paper is just taking the simplest case and not doing that.
I have a question regarding the code. So by counting basically the time periods where someone is poor, you're not interested in the pattern. If someone falls out of poverty and escapes again, or if it's more like a long time period out of poverty and then a long time period in poverty. Do you at some point recover this information, make use of it, or?
Yes.
Okay.
So for now, you are right, very correct, because some of the papers in the literature say it's 3 adjacent periods, or it's X percentage of periods in a given time, like 3 out of 5 periods, or whatever. So there are different ways that the chronic poverty literature, in unidimensional terms, has defined chronic poverty. And we are blind to that. We're neutral, as it were. But what I'll do at the end is actually say that my druther is actually to analyze panel data according to poverty transitions and patterns, rather than necessarily making a measure. But you can make a measure and break it down by these patterns of transitions in and out of poverty, and that's much more illuminating than anything else empirically in our very limited experience. This is new, so there's not that much in terms of empirical applications. So we're going to call this vector E of I, the number of periods in which the person was multidimensionally poor. And then we are going to set some cutoff, tau, which is the number of periods a person has to have experienced multidimensional poverty in order to be identified as chronically poor. Yeah. Sorry.
I have one simple question. So for the row 2, it's like 0, 1, 0, 1. So the person is oscillating between poverty and not poverty.
Yeah.
So is there any significance if these two are subsequently together or they're... So
Not in this. This is what I'm saying, is that there are people that would like to do some curvature for that. We're not. We're just being in an accounting-based approach across periods. In the paper, you'll find a review of the alternative approaches. And we're not saying this is the best. We're just sort of saying this is something that's a way of collecting the data. Yeah. So we are identifying people as chronically poor. Notice that tau could be 1. And in that case, our vocabulary doesn't really work, because a person could be chronically poor. They're poor in any period. And people have said, well, maybe chronically poor requires intersection. They have to be poor in all periods. So the word chronically, you may have to play with a little bit. But tau can take any value from 1 to t, the number of periods. And like k, it is weak. So if the number of periods is greater than or equal to tau, the person is identified as chronically poor.
Greater than equal to, or?
Yes. Yeah, sorry. Put that the other way around.
Can we have the initial tau constant be 1 less than tau, because we are talking about chronicle poor, and 1 time period.
That's what I was just saying.
Yeah.
Mathematically, tau can be 1. In which case, you should really rename chronic poverty to something else. But anyway, we're using that term. We're simply showing how a measure can take different temporal cutoffs in terms of the proportion of time periods. The easiest way to think of tau is, in a sense, as a proportion. If they're deprived of at least half of the periods, they're deprived of a quarter of the periods, all of the periods. Then, as before, this is going to look very familiar. You censor the matrix, so you do a double censoring. So this matrix, you simply censor the poverty of the person who was poor in only 1 period, in less than tau periods. Okay? And so you mark that by saying it's a Q that's censored by K and it's censored by tau. So you keep track of how you are censoring it, because in fact you're going to play with different K and tau values when you implement this. So that is with this identification matrix. But recall that behind each of the columns of this identification matrix is a matrix, let's think of it coming this way, of sensor deprivations. So then you are going to recensor those original CIK vectors by tau, which means a lot here, that you are going to censor all of the deprivations there. So you return to each original deprivation matrix, the G0K matrix for each period, and you censor the deprivations of all the people who are not chronically poor. And so their deprivations match that of the identification matrix. Sasha, are you exiting?
Sorry.
Okay. And so what you are left with is an array of matrices, of basically layers of matrices, tau layers, where the only ones that you see belong to people who are chronically poor. Okay? And then you take the mean of that set of matrices. So you add up all the ones you see in every period, you divide by all of the total of the matrices in all the periods, and you have your measure. So it's linear, again, it's additive. So formally, the chronic M0 measure for achievement X, given the deprivation cutoffs, is the mean. So you're taking the mean across the number of people, the number of dimensions, and the number of time periods. So that's going to be the total n by d matrices for t time periods, n dt, of all of the people, all of the dimensions, and all of the periods of the weighted deprivations that you're experiencing. The weights apply to the dimensions, not to the time periods. Okay? And that's given k and tau. Now, just as we explained that the M0 matrix, and remember that the weights here, as I've explained it, just for simplicity, add up to D, and that's so that it can be a mean. If you take proportional weights, then you have to do the extra division. But just as M0 could be explained intuitively as H times A, a chronic measure can be explained intuitively as HC, which is the percentage of the population. And remember, we're restricting our sample to people for whom we have data for all periods. We're a percentage of population who are chronically poor. AC is the average intensity experienced by chronically poor people in all periods in which they are chronically poor. Okay, because you're again adding the time dimension. And D is nu, its duration. So it's basically, what is the average duration? So if tau was 50%, what's the average percentage of periods in which each chronically poor person was poor? It could be 50%, it could be 90%, it could be 100%. So what's the average duration of chronic poverty among the people who are chronically poor? So again, the denominator is the people who are chronically poor, chronically multidimensional poor. So we're now getting a little bit more dimensional than before, but are you with me? So that's the key idea, that's the key intuition. So we're adding this new factor which takes us out into the dimension of time, and it also gives us a sense of, comparing two populations and the chronically poor, what's the average duration? How does the head count, intensity, and duration vary? So this is what it looks like: 3 dimensions, 3 people, 3 periods. And so you're basically taking a box of 3 matrices, 1 per period. You're taking the mean of the box. Or you're looking at the percentage of people who are chronically poor, the average intensity of deprivations they experience for the people and the periods that they are poor, and the average duration of chronic poverty among the chronically poor people. So that's written out in English. Any questions there before we go into dimensional like compositions?
Getting back at the idea of kind of the continuity of duration, would we kind of think of this almost as like a subgroup decomp, where we can see how continuous in poverty they are before there's a break, like the average cluster? I don't know if there's been any thought given to this that our two colleagues have carried out to do, so I was just figured I'd bring it up.
So you can have different tau cutoffs, and you implement them all just like you implement all Ks. To sort of see, okay, who's deprived in every period, what do they look like? Who's deprived in X percent, or that percentage. It really depends on your data, because if you have very different levels of time between the waves, then you will need to modify this, and then you need to modify the principles. And the paper was just starting with what was clear and simple. If you're a wonderful regular, either silk or something that's every year panel data, then you can work on that.
Put there D instead of 1 because K must be the cutoff, that is the number of dimensions. No, the K less than equal to AC less than equal to 1. So K is expressed in ratio, right? Ratio of the dimensions which will be given cutoff.
Here,
Yeah.
yes, K is percentage. Yeah, sorry if that's confusing. That's a proportional K. Rather than
And also the same equal you can write like for the last one, that tau
Yeah.
less than equal to DC less than equal to 1.
Exactly. Yeah, tau is a proportion. Here's just an example of how to compute. So the matrix, you can obviously compute the percentage of people who are poor. This is 2. People are chronically multidimensionally poor. But this is how you compute duration. So duration is a new intensity. Duration you compute from the identity matrix. So this is the identification matrix Q. And then just as you did A from the deprivation matrix, you compute D from the identification matrix, and you divide again by the number of chronically poor people, not by the population. So it's 2/4 plus 4/4 divided by 2 because 2 people are chronically poor. The average proportion of time period that the chronically poor people existed in poverty was 75%. Okay, so A, as before, you compute off of the doubly censored deprivation matrix, but D, you compute off of the identification matrix. I need to have different colors for these matrices so you don't get confused. And now people might say, well, that's quite interesting. But there were some people who are multidimensionally poor who are not chronically poor. Who are they? And so it can be very useful and intuitive to actually construct 2 sets of people who are mutually exhaustive. Which doesn't mean that they're tired. It means that together they add up the whole population of poor people. Okay? And call one transient poor and one chronic poor. Of course, depending on what your tau cutoff is, depends exactly what that will be. But this is just simply, you can add them up, and you do the exact same thing, except for you look at people who are multidimensionally poor in strictly less than tau periods, and they will be your transient poor. And then you can look at all of their indices in the same way, and they will add up to Q, the number of people who are multidimensionally poor. Okay? So they're very simple ways of keeping everybody in view, not just focusing on the chronically poor.
Why is it sum to Q, not when?
We're simply looking at the number of poor people. And some of the poor, a subset of them will be chronic and a subset of them won't be. So there won't be what we're going to call transient. So then let's get to the dimensional and percentage contributions. And there are really 2 ways of doing this. And it's quite, again, you have to have quite an orderly mind not to get confused. Because you can do the dimensional breakdown per period using the doubly censored matrix. Similarly, you can do the percent contribution per period using the doubly censored matrix. But you also might want to aggregate the whole array and look at the dimensional contributions and the deprivations. And you also may want to look at the average duration of deprivations in each indicator. That's really important, actually. That's really interesting. In what indicators are people always poor, always deprived? In what indicators really is it once or twice? And is there more volatility? It's quite interesting to look at the sequence that deprivations afflict people and the sequence of deprivations being alleviated. So probably with more detail that you want, these are the single period indices you pull out of your doubly censored matrices, and these are the chronic indices that you pulled out of the array of matrices. So I've already talked about more than half of the page, so you can relax. But for each dimension, you can look at the average censored head count ratio of dimension J among the chronically poor people in all periods in which they are poor and are deprived in dimension J. So that's a bit of a mouthful. But what you will be doing is basically taking the information from the array of deprivations and computing this. And the M0C, the chronic measure, is obviously the weighted sum of these. And you can also look at the average duration of deprivation in each dimension and the percentage contributions. So you can do that across all periods as well as per period. Per period it's easy. You have your doubly censored matrices. The only thing that's different is they're doubly censored. And each period-specific index is the same as what you already know. But again, to summarize poverty across all periods, it can be useful also to have these descriptive indicators. So that's an example of how to make a chronic measure. I think it probably has too many drawers, too many windows, too many options to really take off in policy. It's probably a little bit too complicated. So I think that alongside that work, which is probably good for academic stuff, in a sense the empirical edge will come from the kinds of analysis that can analyze questions that only panel data can answer. And this primarily has to do with the sequence. The deprivations strike people and the deprivations lift. The kinds of deprivations that are present in non-poor people and the kinds of deprivations that, if they are present, push people into sort of a kind of chronic poverty. They're poverty traps. So I think it's that kind of analysis, which you can only do with panel data, which will provide the most value added for the empirical studies. So let's look first a little bit at just the basics of descriptions. Let's presume we have 3 periods. We have people who are poor in every period, so they're chronically poor. We have people who are poor, non-poor, poor, or non-poor, poor, poor, non-poor. And then either non-poor, non-poor, poor, or non-poor, poor, poor. So they fall in and stay in and move out. So they were poor, non-poor, non-poor, or poor, poor, non-poor, right? So I intended to put a little thing there, but I forgot. And you can do translation matrices if those are convenient for you.
That can be completely non-poor also.
Yes, yes. Those are also interesting. But for poverty analysis, what we want to know is among these groups, how do they differ? So very fundamentally, if you simply decompose, and often you have more periods, and as you have more periods, you'll have more possible patterns of transitions, and you'll want to then segment, and insofar as your sample permits, and it's very much a question of your data, find some subgroups which you can justify breaking your sample into, where you can study different patterns or different patterns of transitions. So here are some of the kinds of questions that you will want to analyze. In some cases, you'll simply want to describe or analyze determinants or demographic features of the differently poor groups in terms of the different poverty dynamics. And then for example, the people who are chronically poor, do they have a specific caustic combination that everyone who's chronically poor has these 2 deprivations going on? So once they're hit by them, they can't get out. So that's obviously there's a huge literature on poverty trap in unidimensional space, but trying to identify those caustic combinations of indicators is also interesting. And for people who are chronically poor, to what extent is there actually a change in the composition of their poverty? And to what extent do they sort of walk every period with the same deprivations going on in their life? Which are the ones that change among the chronically poor and which are the same? And I think, of course, for policy, the most interesting one is, which is regularly asked to us in the policy streams, is in a sense, which sequence of policies is going to have the biggest tie-in? Is it going to have the biggest impact if you educate the kids or if you feed the kids? So if you're resource constrained, you have to sequence the policies. Which do you do first? And that's where the impact evaluation, we'll talk about tomorrow, it's where, day after tomorrow, it's where some of these, they could be teased out further with those kinds of data sets. And then, of course, looking at not only the dynamic subgroups, but then also different kinds of population decompositions and understanding their chronic poverty patterns. So all of this is done simply by computing multidimensional poverty for each period, but not constructing a chronic poverty measure. So you have forgotten, restarted your brain, erased your computer of the chronic poverty measures. You simply have poverty measures each period. You have your dimensional breakdowns, and the censored headcount ratios and the percent contributions, and then you'll be analyzing them to look at some of these questions. That there's no way that you can obtain from cross-sectional, repeated cross-sectional data. And here are more questions. So if you're looking for research topics, we're full of them. But these are unanswered questions that really, we need a good set of empirical papers to start to flesh out these issues. We also observed that there could be interest in policy in terms of more formally seeing how poverty changed in terms of the headcount ratio, people who exit poverty, and in terms of changes in intensity. So Anna presented Nepal, and the changes in Nepal were graphed according to the reduction in headcount ratio, so the percentage of people who are poor and how it changed, and the change in intensity, to what extent the average deprivations per pupil experience changed. But it might be quite interesting using panel data to look much more closely at that, to say, well, who popped out of poverty? And to what percentage of poverty reduction was due to people popping out versus due to a reduction of poverty of the existing poor. It is impossible to answer that question with cross-sectional data. There's no way. And it's trivial to answer it with panel data. So these are the groups that are mutually exclusive, that in a sense categorize in a two-period world the non-poor who are non-poor in both, those who are poor in both, and the two directions of transition between two periods. And then we can look at the changes in the headcount ratio. It's the original change in period 1, and those who exited or those who entered, and how they changed. So the difference between those who exited and those who entered as a proportion of the total population is, in a sense, the change in the proportion of poor people, which is impossible to obtain with that precision for cross-sectional data. And when you have that, you can then also decompose M0 to look at the extent to which changes in M0 were caused by these different kinds of transitions in different groups. And so, just to give a very simple society, the six-dimension society, this person is deprived by intersection in all 6 dimensions, 5, 4, 3, 2, and k equals 2, so this person is non-poor and 5 people are poor in period 1, and in period 2, lots of poverty is gone, and 4 people are poor. This person's fallen into poverty, these 2 have left poverty, and these have different numbers of deprivations. So here you can see the overall headcount ratio and the percentage change, which we could do with cross-sectional data. But here you can see much more the detail. Okay, this person had 4 and got rid of 1, so got rid of this one. So what is this one? Okay, you can then go up and see what particular deprivation this was. This person got rid of this one. This person got deprived in this one. So it's this kind of really analyzing both who entered poverty, which was this person, who exited poverty, which were these 2, and then the dimensional changes that enable you to say much more clearly what percentage of the change in M0 was due to people leaving poverty or due to changes in the intensity of those who remain poor. So that's a bit of an illustration. So these are just suggestions of kinds of work that you might do when you have a data set to analyze. Is anyone interested in thinking about Shapley decompositions or theoretical decompositions with repeated cross-section data? If you're not, then we can have a time for discussion and then tea. If you are, I can go through it.
Yeah, I
One? Yeah? Okay. Okay, we'll go through it.
Can I have a question?
Yeah?
When we say that we have to have a repeated cross-section data to conduct such kind of analysis, I understand that.
No, you can't with a repeated cross-section.
I mean, when you say we can't do that, well, suppose I am looking at a particular region or particular ethnic group, and I have representative sample in both the time periods. Now I find that in a particular dimension, suppose that ethnic group is chronically poor from the sample which is representative of the population, then why can't I say, from the repeated cross-sectional data that this dimension, I mean, people of that particular group or particular region is chronically poor in that particular dimension?
So by knowing they are chronically poor, how do you know they are chronically poor with repeated cross-section data?
Well, I mean,
I looked, by the way, at the data for South Sudan, and every person in the sample is deprived from something. It's interesting.
well, I mean, how do I know if you ask? It's not that, obviously I'm not tracking a particular household because I don't have an identification for that.
Right.
But I know when I'm taking a sample, it is representative of population. So what I'm concluding on that time period is about the population from my sample. So what I'm concluding this time period is also about population from that sample. So on that basis itself I can say, I would not pursue know that which household actually is chronically poor, but I can say as a group, that group is chronically poor in that particular dimension.
But to know chronically poor, you have to know that they're poor over several periods.
Yes, I mean I
So you
have.
won't know that from one period of data.
No, I'm saying there are multiple period data. Multiple period data.
No, we can talk later, but you can't do it. I'm sorry.
I think
Yeah.
Different cross-section, different groups. As groups in 2007 and 2010 and 2012.
Exactly.
You can do that. I'm not sure that for countries. But
That's
That's also, I was saying that that particular group is really poor from particular dimension.
not chronically. You can say they're the poorest.
maybe not chronically.
Because it is over dimension, over time periods. That's what I'm saying.
Yes, on a sheet of paper. I think the paper has something in it. So all of these indices, it's H times A times D times T. So all of that work has been done, and the empirical work has been done. The properties have been partly done, because it does the monotonicities and whatever. And time, again, the same kind of time monotonicity, which is equally weighted time period. But, yeah, the paper got so long that it was included in the working paper. So it's now just in draft form. Yeah. Okay, yeah, it's not?
I also heard that you told her that most of the empirical work has been done. So I wonder how many observations do you have left after, because you have this condition that everybody is supposed to be, you have an observation for everybody for all of the years, and if you manage to keep the representation of the sample.
Yeah. Yeah, so I mean, this was an illustrative example. And so you just keep it fixed, and it was 3 periods. It was with Chile and Casen data. Yeah, that's because with Casen you have BMI, which is sort of cardinal, you have years of schooling, which is cardinal, you have income, which is cardinal. So we went just to 3 indicators to do the M1 and 2 measures, and demonstrate them. I don't think it's ever going to take off again in empirical terms. So I think we can work it through in terms of methodology, but I think probably people are going to be much more interested in the ordinal, which is why we decided to focus more on the ordinal. Yep.
You might have mentioned this, but what about people who move in and out of eligibility over time for a certain measure?
No, that's huge, actually. So Anna mentioned the demographics. So all of this, both the repeated cross-section and the panel data, you have to really look carefully at demographics. So the demographic shifts to the population, the migration, internal migration of countries, people changing whether or not they're indigenous by expressed identities. All of these really mess you up. And it seems that the only way to deal with the demographic is to look at whatever you can in terms of census data, to look at other studies on the demographics. But it's really difficult to even to reconcile, and as you know, there are often political views on populations. And I think it needs a lot more work with demographers, just thinking this through. Because in the case of households with and without children, if you have a child indicator, that's going to change. And so there will be an aging factor that way across all households. Yep.
Do you have any recommendations on how to correct for attrition? Because especially when it comes to transitions into and out of poverty, this might also relate with geographic mobility, and then they're out of the sample.
Yeah.
Do you apply any kind of correction term for this, or that's the end of the story? And because many people are quite pragmatic about this, right?
Yeah.
So
we've just said, look, that's not our expertise, so we're just using what others have done, and we're focusing just on the methodology. But I recognize that, I think it's a bigger issue than often people realize when you're looking at changes over time, just from the bits that we've seen. Okay, what can you do with repeated cross-section data? Until I'm proven wrong, and I'm happy to be proven wrong. I hope that you do prove me wrong. But under my limited understanding, you can't decompose M0 with the same empirical precision as when you're using panel data. So we're going to be very crude, and we're now going to try to track two people, and we're going to call one group the movers, those who move out of poverty, and the others the stayers, those who stay in poverty, right? And more precisely, we're going to presume that the movers are about the same as the difference in the head count ratios, but we don't know, because some people will have moved out, others will have moved in, so there's going to be this flux. But we're simply going to presume that everybody who left poverty and nobody came into poverty, right? And then the stayers will be the ongoing poors. This is if we're presuming poverty reduced. The people who are poor in both periods, plus any replacement of the previously poor people by new poor people. And that's going to be, in a sense, the head count ratio in period 2. Okay? So this is a change in head count ratio, which Anna taught you to compute. This is the head count ratio in period 2. So we're making some pretty big assumptions, pretty simplifying assumptions. And what we're going to do is assume that poverty went down, just for simplicity, to make one presentation about the direction. And we're going to presume that in terms of the people who entered poverty, it's empirically small. So the number, as a proportion of the total population, those who entered poverty isn't so big. It's not that there was a natural disaster. It's not that there's been an influx of migrants, but that it's basically quite small, and basically poverty went down. And so we are then going to decompose the change in M0 into two factors. One is the percentage of poverty that changed times what we estimate the intensity to be of those who left poverty. And plus the percentage of people who stay poor, so that is who remain poor in period 2, times the change, any change in intensity of the ongoing poor. So it may be that over time, the average intensity went down even for people who stayed poor. Okay? And that would be reflected here. And it may be that those who left poverty were the barely poor. They just picked off the barely poor people. It may be that, as in the example I showed you with panel data, they've looked at the poorest of the poor, and they've looked at a pocket of poverty, and they exited poverty totally. So you could have various different intensities among those who exited poverty. But that this would be the change of M0. Now the problem is that we don't have either of these. We don't have the original the change in poverty among those who remained poor, and we don't have the intensity of those who exited poverty. So empirically, why don't you play with your data? So why don't you take the weighted sample that equals delta H? Okay, let's say delta H is 10%. Take the people who are poor, whose weighted sum is 10%. And rank them according to the CI, censored CI vector, and take the ones first who have the lowest intensity. So presume that the barely poor left poverty. And then go to the other end of your sample and look at the poorest of the poor. Take the 10% of your sample, weighted, and look at their intensity. And you use those to create the bounds of the average intensity of those who left poverty. And then you solve for A0. So that will, in a sense, give you the upper and lower bounds from your own data set of what the minimum and maximum could be under these two conditions. The poorest people moved out of poor, or the least poor people moved out of poverty. So Anna did this. So these are a few countries, and she estimated the upper bound and the lower bound. So for example, in Ethiopia, the upper bound would be that the people who moved out of poverty had basically average intensity of 99%. And the lower bound, those who moved out of poverty had an average intensity of 38%. And if it was 99%, then basically the delta H contributed 68.7% of the change in M0, and the reduction in intensity, a third. And the proportions changed in the other scenario. So the reduction in intensity would have contributed much more to the change in Ethiopia's poverty. And similarly for Nepal, similarly for the others. When you put in the empirical bounds, then in a sense what you can think of as being the contribution of the change in headcount ratio or the change in intensity vary quite considerably in the different scenarios. In some, like Senegal, which didn't have a significant reduction in poverty, in either case the Sayers effect is larger. And in some, in either case, it's smaller. But in some, that even swaps. And so that brings us to one of the problems with the Shapley decompositions and the theoretical decompositions. When you do these decompositions, you are implicitly making an assumption about what this delta A is. So let me show you what you do. The theory-based approaches decompose it between incidence and intensity. And for example, this is work by Maurizio and Gaston, which I think is very good because we have to flesh these things out and link them to the other kinds of theoretical decompositions. And what they do is they assume that everybody who left poverty had the same intensity as the intensity of those who were poor in period 2. Okay? So that's their assumption. And the change in intensity among the originally poor was a simple difference in intensity between the two periods. And according to that, then they're able to decompose into an exclusive intensity effect, exclusive incidence effect, and a joint effect. So that's the equation. This is the decomposition of M0 into the effect from people who entered and exited poverty, the effect among the ongoing poor, and this interaction. The Shapley decomposition is really neat, and it's the same whether you're using growth Shapleys or poverty Shapleys or whatever, but it basically gets rid of this interaction effect. And this is based on Revalian and Hoopy, and Jose Manuel de Roche came up with the methodology extending Revalian and Hoopy. And what he assumes, or what Shapley assumes, is that the people who left poverty had the average of the intensities of the poor in the two periods. So intensity in period 1 plus intensity in period 2 divided by 2. And he assumed that Shapley assumes that the percentage of ongoing poor is the average incidence of the two periods. So that if you take the average of the headcount ratios in the two periods, these people actually are ongoing poor. And that's, then you have a very neat decomposition in a Shapley effect, where you decompose simply into an effect on M0 of reducing intensity and reducing incidence. So that's the decomposition of the Shapley. So in both of those cases, what they've done is basically taken a hard decision and said, okay, we're going to make some assumptions because we can't measure it with repeated cross-section data. And then we'll decompose and we'll give you a precise answer. So this is what we saw before from the empirical, and this is the Shapley decomposition. And so what you'll see is that in this case, for example, Shapley says that the incidence was 45% in Ethiopia, and the contribution of intensity was 55. And that is between the upper and the lower bounds, naturally, in every case. And it seems appealing, because you can say, look, 86% of the reduction of poverty in Peru was because of people leaving poverty, and 14% was a reduction in intensity of the ongoing poor. So it has the appeal of trying to provide very simple point estimates for policymakers. But empirically, we have no idea if it is right. And it's the assessment that these empirical bounds are so far away in most cases that led, at least me, and I better take responsibility, to conclude that the assumptions are too strong for policy use. And so we shouldn't necessarily do Shapley and just sort of produce these numbers for policymakers without making explicit the assumptions and some of the uncertainty associated with them. But empirically, you can compute them all, and empirically, you can analyze them, and with the upper and lower bounds. I'll leave the example. The example is very simple, but you can do it yourself if you want to figure it out.